Hi everyone, I'm doing video number 8, guys. Simply means I'm doing the 8th question from the grade 11 mathematics paper 1, which was written in the province of Gauteng in the year 2023. Just know that there are other videos, guys. Just click the link on the description. It will take you to the full memorandum whereby you can answer the questions with me. If there are things you don't understand, please do write on the comment section. I'll definitely come back to you and explain. Okay, sketched below is a parabola OJ and a straight line K with equation K of x is equal to 1 over 3x minus 1. Okay, and then we are told that T is the turning point of J, and J cuts the y-axis at y is equal to 6 and the x-axis at R and Q. J and the straight line intersect at P and Q. Okay, V is the point on J and W is the point on K, such that VW is parallel to the y-axis. Simply means VW is a vertical line since it's parallel to the y-axis. Okay, we are supposed to show that the equation of J can be written like that. J of x is equal. I can use this equation because I have a turning point minus P plus Q, whereby both P and Q represents the coordinates of the turning point, right? So J of x is x minus 1 squared plus 8. And then now all I need to do is to substitute the value of any point on the curve of J for me to find the value of A. Altogether, I can take the y-intercept or the value of R since I'm given the coordinates over there. Altogether, the y-intercept, I know that y is 6 and x is 0. Okay, and then all I need to do is to just substitute. When I take the 8 to the other side, it will change the sign. I will have 6 minus 8, which is just negative 2. I will have A here. So I know that A is equal to negative 2. Then all I need to do is to substitute it in the equation. Negative 2x minus 1 squared plus 8. I just need to remove the brackets. Whenever I do so, I will have negative 2x squared plus 4x minus 2. I still have a plus 8 there. This will be negative 2x squared plus 4x plus 6. So I've proven that the equation can be written like that. I just needed to find the value of A and then just work. They want me to find the average gradient between the average gradient of J between 2 points where x is 1 and when x is 3. Okay, the equation is J of x is equal to negative 2x squared plus 4x plus 6, right? I only have the x values. I want to find the corresponding y values. So J of 1 is simply negative 2 times 1 squared plus 4 times 1 and 6. When x is 1, the value of y is 8, and when x is 3, the value of y, let me check. When x is 3, I'll have 6. 6 plus 12 is 18, minus 18, that's 0. Okay, so the average gradient m is just y2 minus y1 over x2 minus x1, right? Y2 is the y value when x is 8, so I'll say 8 minus 0 all over 1 minus 3. So this will give me 8 over negative 2, which is just negative 4. So the average gradient between those 2 points is just -4. Okay, and now I'm supposed to calculate the coordinates of the of point P, the intersection of J and K. Where's point P? There's point P over there. Point of intersection, guys, always the time. I just need to equate the two graphs and then solve x. I'll simply say J of x is equal to K of x. J is equal to -2x squared plus 4x plus 6, and then K is equal to 1 over 3 x minus 1. I'm solving x here. The only unknown I have is x. Whenever I solve x, I don't want to have fractions. That means I must multiply each and every term in this equation by 3. I'll simply have -6 x squared plus 12x plus 18 is equal to x minus 3. So this is -6 x squared plus 11x plus 21 is equal to 0. For me to solve x, I must make sure that the value of a is positive. That means I must divide everything by -1. So I'll simply have x squared minus 11x minus 21 is just equal to 0. Then I'll just open two brackets. 6 1 7 3 that's 18 7 when I subtract, yes, so these are my brackets. I'll have 6x and 7x and 3 minus and plus, then x is simply -7 over 6, or x is just 3. That means the value of q there, we have x is equal to 3, and this one is the one which is at point P. So for me to find the corresponding y value, I can simply say k of -7 over 3 is equal to 1 over 3. It's over 6, right? Not over 3. It's -7 over 6 minus 1. Let me write neatly. K of -7 over 6. Whenever I see x, I'll just substitute -7 over 3 over 6 rather minus 1. So this will just give me 1 over 3 multiplied by -7 over 6 minus 1. That's 25 over 18. -25 over 18. So the coordinates of P, I simply have -7 over 6 and then -25 over 18. Those are the coordinates of P. And then now I'm supposed to calculate the maximum length of VW. VW, remember that VW is a vertical, it's a vertical line, right? Why am I saying it's a vertical line? Because line VW is parallel to the y-axis. So if the y-axis is a vertical line, that means VW is also a vertical line. Okay, how do I find the length of a vertical line between two graphs? I'll simply say the distance of D will be given by, or let me just say the distance of line VW will be given by the top graph minus the bottom graph. If you can check here at VW, J of x is above K of x. That's why I'm saying top minus bottom. The top graph is simply -2x squared plus 4x plus 6. This will be minus 1 over 3x minus 1. Alright, together. and then I'll simply have negative 2x squared plus 4x plus 6 minus 1 over 3x plus 1. Negative 2x squared. Whenever I add 4x minus 1 over 3x, this will give me 11 over 3x plus 7. Okay, this is the equation that will give me the length of VW, right? But they just don't want any form of length, but they want the maximum length between the 2 points. Are you together? For me to find the maximum length, I just need to treat it as me finding the y value at the turning point. That will be the maximum length. Okay, how can I find the y value at the turning point? I first need to find the x at turning point, which is x is equal to minus b over 2a, which is equal to minus b is simply 11 over 3 all over 2a. So this is times 2. So this will basically be 11 over 12. Let me confirm. Negative 11 over 3. Yeah, that's 11 over 12. Okay, so therefore the maximum length of VW is 2 multiplied by 11 over 12 squared plus 11 over 3 multiplied by 11 over 12 plus 7. Whatever answer that I'll get there will be my maximum length. Negative 2 11 over 12 squared plus 11 over 3 multiplied by 11 over 12 plus 7. I simplified 625 all over 72, which is simply 8.68 units. So the maximum length is just 625 over 72 units, or it's 8.68 units. That's the maximum length. Ne? Another way, guys, we could have done that. I was just avoiding too much work to do. Ne? Whenever you are here, you can simply complete the square, and whenever you complete the square, you will find your expression as to be in this form: x minus p squared plus q. Q will be the maximum length. All right, together you can just complete the square. You'll still get the same answer as we did, which is 625 over 72. You'll just find the same answer as well by completing the square. Ne? Okay, use the graph to determine for which values of x is j increasing. For which values of x is j increasing? Remember that j represents a parabola. Ne? So I will just scan my graph moving from the left to the right. Are we together? Moving from the left to the right, from left to the right, ne? I can see that my graph keeps on increasing until it reaches the turning point, and then it changes direction, and then it will start decreasing. Are we together? So my graph is increasing whenever x is less than 1, because the x value at the turning point is just equal to 1, right? Okay, second question, they want us to find, okay, this thing can be rewritten as j of x over k of x greater or equal to 0, because you can divide both sides by negative, just to remove this thing over here. No? Whenever you divide by negative, obviously the sign of the inequality will change. Are we together? So I'm dividing two things and the answer is greater than 0, which simply means that the things that I'm dividing, both of them have the same sign. Are we together? So remember that I have j of x all over k of x. I'm looking at the two functions where they have the same sign. That's when both graphs will be above the x-axis at the same time, and both graphs will be below the x-axis at the same time, right? If I move from point R to the left, I can see that both of my graphs are below the x-axis at the same time. Are we together? But if I move from point R maybe to point Q, I can see that J is above the x-axis, but K is not above the x-axis. So that one is not applicable. Then if I move from Q going to the right, the graph of K will be above the x-axis, but the one of Q will be below the x-axis. So in this case, the only solution is in here, when x is less or equal to the value of r. So when x is less or equal to -1, that's the only solution we have there. Are we together? Okay, and then now we are being asked, for which values of k will j minus k equal to 0 have two distinct roots? Remember that the graph of j can be written as -2x squared plus 4x plus 6 minus k. Let me write minus k in a different color there. Minus k is equal to 0, right? Okay. Basically, k is a translating factor. K just moves my graph either vertically up or vertically down, or together. Okay. Whenever my turning point is just above the x-axis, since my graph is a set graph, I will always have two roots. Are we together? However, if my graph, if the turning point is at the x-axis, like this, I will only have one root, which is here. But if my graph is below the x-axis, I will never have roots. Are you together? There won't be real roots of x. Are you together? So I want to have, what does this thing say? For which values of k will this equation have two distinct roots? This equation will have two distinct roots if my graph is just, the turning point is just above the x-axis. Are you together? So how can I attempt this question? Okay, you must know the distance between your turning point and your y-intercept, right? The distance between these two is simply 2 units. Are you together? So whenever my graph turns at the x-axis like this, it simply means here I know that here y is 0. That means y will be -2 over here. Are we together? So for my graph to have two distinct roots, the value of the y-intercept c, c must just be greater than -2, because whenever c is greater than -2, I will have my graph like this. Are you together? Then I'll have two distinct roots. I'll have my graph like this, two distinct roots. Are you together? So I just want to have the value of c, which is the y-intercept, to be greater than 2, right? So in this case, what is the y-intercept? Remember that the y-intercept is represented by the constant term here. So this guy over here is the y-intercept. So I'll simply say this is 6 minus k. It's just greater than -2. That means -k is greater than -8. That means k has just to be less than 8. K must be any number which is less than 8 for me to find two distinct roots for this equation. Are you together? So k must just be an answer which is less than 8. K is less than 8. This is the solution for 8.6. I really hope that, guys, the video helped you out. Just stay tuned, guys, and wait for more videos. Thank you.